Okay, so the last thing we'll talk about in chapter 5 is this inequalities in one triangle. This is mainly for the ACT and SAT. There are questions like this on that test. So we're going to go into this. I really appreciate the triangle inequality theorem, which we'll talk about in a second. Okay, so the first one has to do with ordering sides and angles. Okay, so these two ideas say if two sides of a triangle are not congruent, right, then the larger angle lies opposite the longer side. So notice in this picture, this is saying that xz is bigger than xy. So the angle opposite of xz, so if this is xz, the angle opposite of xz is angle y. Notice that angle y is not used in the naming of xz. So that's a very important idea. So if xz is bigger than xy, then that means angle y would be bigger than the angle opposite of xy. Now, this is where it gets tricky because xy is over here, so it might be hard for you to identify what angle is opposite of xy. But again, if the side is xy, then z is the opposite angle. It's the letter not used. So this relationship allows you to say something about this angle relationship. Now, the same thing happens in the reverse order, right? So if you have two angles that are not congruent in a triangle, then the longer side lies opposite the larger angle. So in this picture, they're telling you that angle A is bigger than angle B. So the side opposite of angle A will be bigger than the side opposite of angle B. So again, it's very easy for angle, just draw where it opens up to. So it opens up to segment BC. So that means BC must be bigger than, and now angle B is here. It opens up to side AC. That means BC has to be greater than AC. And you can use this to order your triangles, sides, and angles in any triangle. So I'm going to do it on Desmos geometry real fast for you. Okay, so on Desmos geometry, I'm going to quickly draw us a triangle. So I want it to be obvious that the sides are not the same. I'm going to call it ABC. Here's A, here's B, here's C. So obviously I think AC is the longest side. So let's measure it. 8.2. Obviously AB is the shortest side. Let's measure it. 3.17. And obviously BC I think is the middle side. And maybe not obvious, but it is 6.19. So if I wanted to identify the angles, maybe from smallest to least, well, because AB is the smallest side, that means angle C is going to be the smallest angle measure. Now watch when I measure it. Now notice C's must be my vertex. So I'm going to do B, C, A. So C is 19. Pretty small, right? 6.19 is my next biggest side. So the angle opposite of it, opposite of BC, which is angle A, is probably the next biggest angle. A must be my vertex. Name it the second letter. B, A, C. So it is a little bit bigger than angle C, right? And then I believe that AC is, or I know it is the longest side. So because AC is the longest side, angle B is going to be the largest angle. So I'll go angle A, B, C. And there we go, right? And it is the biggest angle. So again, this was an obvious example for you. So if I quickly take a picture of this so I can write on it, give me 1 second. There we go. Okay. So again, if I wanted to order, okay, good. If I wanted to order these sides, so the sides were AB is the smallest, AB is less than BC is less than AC, right? So then the angle that is not used in the naming of this side is going to be the smallest angle. So that's the measure of angle C, and angle C is the smallest, followed by the angle not in BC, which is angle A, which is the next biggest, and then followed by the largest angle opposite of the longest side AC, which would be the measure of angle B, and it's true. So this is how you use a triangle and the lengths of the sides to order the angles and vice versa. Okay, now the other problem I want to take a look at is, or the other idea is this isosceles, or I'm sorry, the triangle inequality theorem, which I think is, again, very important. So first of all, I have a picture up here. So look at these two triangles, right? One is a triangle, one is not. So look at these two, this triangle on the left, right? So what can you tell me about the sides of this triangle? Well, aside from them being 3 and 3, right? What if you added 3 plus 3? Well, 3 plus 3 is 6, which is greater than 5, the biggest side, okay? But over here, what if you added 2 and 2? 2 plus 2 is 4, which is not greater than. It's actually less than the longest side of 6. So let's keep that in mind as we look at this triangle inequality theorem. The triangle inequality theorem says the sum of the lengths of any two sides of a triangle must be greater than the length of the third side. Now up here, we have a little bit something better to look at. The sum of the smallest two lengths must be greater than the greatest length. I think that is a more pertinent statement, right? Because this is true, right? Or this must be true for all three combinations. But why try all three? If you use the longest side, xz, of course, when you add xz to any other side, it's going to be longer than that third smaller side. So the only one you have to really use is when the two smaller sides, which would be xy and yz, added together must be bigger than the longest side, xz. Okay. Now I'm going to try to demonstrate this quickly in Desmos geometry to as best I can. Okay, so I'm going to start with a segment. And again, I just want to make sure its length is a number we can work with. So I think 10 is good. Let's see if I can make it 10. There, 10. Okay. So now, again, if the two segments don't add up to more than 10, so say we have this segment of length 5, sure. 4.99, that's 5. And this segment of length, let's try to get 3. Sure, right? They don't connect, right? Even if you try to make this one 5 as well, right? Look, just a little, and you can even bring it down. They would just meet like this all along this side of 10. So if that was 5 and if that was 5, they would just meet there. But if you lift it up, they would not connect. But not until you make one of them, say one of them 7, right? And now this one 5 or whatever it's going to be. Right. Now they connect because what do 4 and 7 make? They make 11, which is greater than 10. So again, I hope this brought to light this idea of the triangle inequality theorem. Okay. So I'm gonna do one problem on Delta Math. I'm just gonna piggyback it onto this video. One problem. All right, so here's the one problem I want to do. So it says determine the length of the longest side and the measure of the largest angle in the triangle shown below. You must use the ruler and protractor for precise measurements. The side length should be the precise to the nearest tenth, and the angle should be precise to the nearest degree. Okay, so in this picture, this triangle looks, it's acute. It almost looks like equilateral. So it's kind of hard to tell which side is the longest side. I think it's going to be JK. But why don't I go ahead and just measure all of the sides really quickly? So if I use the ruler, right, there is a purple dot that's 0 and a green dot that goes there. So that is around 8.123. That's 8.3. Again, I think that's the longest side. Okay, let me check this one. So purple dot, green dot. Okay, that's less than 8, so that's not it. And then green dot here. That's 7. So I was right. It's 8.3. So this side, JK, is the longest side. And it is 8.3. So the longest side is JK and has a length of 8.3. So then automatically I know what angle must be the largest angle. It's the angle opposite of this ruler that doesn't involve J or K, and that's L. So I know that angle L must be the largest angle. And now I have to use the protractor to measure it. Protractor, put the vertex on that purple dot. Now again, the green has to go along the side of angle L, so I'll just rotate it here, make it big enough so I can read it, and it looks like this angle is 69 degrees. That's all you have to do. So don't measure too many things. I would start with the sides and then go to the angle that's the largest because, again, I can use a ruler pretty well. Protractor is a little bit more difficult. Submit that answer, cross our fingers for green, and I got it. Yes. Okay, so this is one type of problem you'll see. There's a couple other type of problems, but I think they're pretty simple enough that you can do them if you paid attention to the video. Okay, all right, best of luck.